Good morning all. So in the last class we looked at constructors. If you remember, this was the example that we were discussing. Like suppose we have a student class. So let me increase this. Say a student's various details are stored like name, age, semester, and the list of courses that the student is doing. And we can have a constructor. So we can have different kinds of constructors, different definitions of constructors. A constructor is basically used to initialize the fields of an object with some default values. So suppose I want to by default initialize the semester of all the students to number 8. I can write in the constructor this dot semester equal to 8. Or another way is I can initialize the value of a field with the value which is given as input by the user while creating the object itself. Like if you remember, normally when we create an object we give empty brackets, right? That is because usually the constructor is empty. But we can also create an object with, we can also create an object with some input. So while creating the object itself, we can pass some input. Then we don't give empty brackets, we give some input. Okay? In that case, such a constructor should have been declared already. That, okay, there is another constructor which takes a number as input and does something with that number. So this is an example of a constructor which takes a number as input. So whatever number you pass while creating that student object, that number will become that student's semester. Okay, so we can declare like that also. We can declare empty constructor where we populate the fields later, or if we know some of the fields values during the creation of the student object itself, then we can pass those values along with the student object, along with the creation of the student object. But for that we need corresponding constructors. An empty constructor which does not take any input, or a constructor which takes a number as input, or a constructor which takes all the details like the name, age and semester of the student as input. It depends on what constructors you define. So for you to use a constructor, that should have been defined in the definition of the class itself as a constructor. So this is an example. So this is using the third constructor. Here we are passing all the details like the name of the student, the age of the student and the semester of the student. So all these things we are passing. In this case, we are passing only the semester. So this uses the constructor which takes only semester as input. In this case, we are not passing anything. So this uses the empty constructor. So this is called constructor overloading. You are defining constructor with in different ways. You are defining constructor with different parameters. So this is one definition of constructor with no parameters at all. This is another definition of constructor with one parameter. This is another definition of constructor with 3 parameters, right? And you can have more combinations. There are 3 parameters like I said in the earlier class, 3C0 plus 3C1 plus 3C2 plus 3C3. So you can choose one parameter, you can choose to pass no parameters at all. You can choose to pass one of the 3 parameters. You can choose to pass 2 of the 3 parameters, or you can choose to pass all the 3 parameters. In this case, we have 3 fields. That is why. Okay. But if you have 4 or 5 or 10, then again it will go from 10C0 plus 10C1 plus 10C2 and so on up to 10C10 like that. So you'll have so many combinations of constructors in case you want to. It's not necessary that you have to define every possible combination of constructor. Whatever you want to, or whatever you think is more useful or will be used more frequently, you can define such a constructor. Okay. But at the same time, say if you want to cover, okay, before coming to that, there is one more thing that I mentioned yesterday, this method. That is, say you want to repeat some statements in multiple constructors. Okay, instead of repeating that, if the statements, all the statements of the previous constructor are used in the next constructor, then instead of repeating all those previous statements, you can just inherit the previous constructor into the next constructor by using colon this with brackets. So what does this mean? So this means, so let me remove this. Whatever line is here, that line is copied into the next constructor automatically. You need not write that line again. Okay? And you added a new line here. Okay? Now in the third one, we are saying again this sem, you are passing an input. Okay? You are passing an input from the previous constructor, and all the statements of the previous constructor are copied into this one. But the previous constructor itself has its own statement and the previous constructor statement. Okay? So this statement is copied into this. Okay? And then these two statements are copied into the third one. So that is like inheritance. So you need not repeat the previous statements which are already defined in the previous constructors. Okay? So that is the use of this colon this. Okay? Whatever constructor you are creating, put a colon and then write this with an input if there is an input, else no input, just empty brackets. It will just inherit the statements from the previous definition of constructor into this constructor. Okay? So these are two things which we saw earlier. Different, so constructor overloading is one thing, and then inheritance is one thing. Inheritance we will see in a bit detail today and later also. Now the thing is, we just saw some 3 different definitions of constructors, but there are many more possible, right? More than 10 constructor definitions are possible just for this class. So do we suppose if we actually want all those constructors, then we have to write all those constructor definitions. That is too much of work and too much of confusion, right? So instead of that, there is another simple method. There is another simple method for giving any values that you want while creating the object itself. So let me close this. So suppose I want to create objects. I want to create say 3 students. One way is I give their values using the constructors which are already there. Another simple method is I can just say var s1 equal to new student, and in this I pass the values directly along with the field names. So what are the field names in the definition of student? Name, age and semester. Okay? Right now don't worry about this course list. Let's just focus on these 3, name, age and semester, right? So suppose I only know the age of the student. I can just say age equal to 17. Okay? Sorry, s1 dot age. No, I don't think that is necessary. Yeah. So let's see. There seems to be some issue, but let's see. there some bracket mismatch? No. So okay, I'll check the syntax and get back to you. But some semicolon or some bracket is mismatching. But the thing is, right now, say you have three fields, so name, age, and semester. Suppose I know only age of student 1, I can just say age. I can declare S1 like this, S1 equal to new student, and I can give the values of the fields that I know of. Similarly, say if I have another student, I can say new student, and suppose I know age and semester of this student. I can just say, or I know only the name and semester of this student. I can say name equal to say whatever, and semester is 8. Okay, so now it doesn't matter how many fields you give and in what order you give them, because you're giving the field name, and that value will be automatically assigned to that during the creation itself. Okay, earlier what you had to do, you have to use a constructor, and that constructor should have been defined there. So if there are 5 fields, then you need to remember all the different constructor overloads that are there, in which order they were given, and you have to give the inputs exactly in that order. No more inputs, no less inputs. Okay, here out of 5, you may remember only 3, and you don't even remember the order of the order in which you need to give the field names. You just know the field names, you don't remember the order. Okay, so you just give whatever fields you remember, whatever values you know of, just give those values during the object creation itself. Okay, so this is object initialization. All right, I don't know why it is not working. I'll check it and get back to you. Yeah. Okay, so this is an easier way of initializing objects, that's all. Okay, so that's one thing I wanted to say. All right, now let's move on to the next topic, that is access modifiers. So we already looked at one access modifier. Can you tell me what that is? Public. Yeah, so the level of access that you want to give to a class or a field or a method, that is dependent on the access modifier that you use. Okay, so there are basically 5 types of access modifiers in C#: public, private, protected, internal and protected internal. Okay, so today we will look at only public and private. We will look at the remaining when we discuss inheritance. So these are the 5 access modifiers. Okay, so why do we need private modifier? Like you already know, you see, you are using a lot of softwares and not all codes are open source. You are only provided with the exe file, or even if you are working with other developers, it's not necessary that they provide you with their entire code. They may just provide you with some functions to access their code. Okay, because we are dealing with objects, and objects have what do we say, objects have some behavior, and also objects have some data. All we need to know is the behavior of the objects. We need not really know the data of the objects, because we just need to get some work done by the object. Okay, say for instance, you order some food in the restaurant. The waiter takes your order and goes inside and tells the chef cooks it, and the waiter brings it. Okay, so imagine now there are 2 classes, the chef and the waiter, and you are also a class like customer. So there are 3 classes. The customer need not know what the chef is doing, what all ingredients or what all process the chef is following. Similarly, the waiter also need not know. Waiter doesn't go and stand beside the chef to see how the chef is cooking. Okay, so whatever is being done by the chef's class, you are only getting the input and output. You give the order to the chef and you get the output, which is the cooked dish. Whatever is happening inside is being done by chef, and you need not even know that. Okay, so classes only need to provide you with an interface to interact with the class or the particular object. Okay, they need not let you in to know how they are doing the logic, what all logic they are following. They need not let you know. Okay, that is for the safety of the system. That's how objects work even in real world. Okay, so some things are kept private, some things are kept public. Usually most of the fields, almost all the fields of a class are kept private. In case you want to allow some other class to change some of the fields, you will not make these fields public directly. You will create some public methods through which your fields can be accessed. I will give an example in a minute, but before that I would also like to mention some 3 basic characteristics of object-oriented programming. These sort of differentiate object-oriented programming from other kinds of programming. So the first one is encapsulation or information hiding, and the second one is inheritance, and the third one is polymorphism. So these are specific to object-oriented programming. They are not found in other kinds of programming like functional programming or procedural programming or imperative programming. You don't find these in other kinds of programming. Okay, so out of these we will be discussing the first one today, that is encapsulation. So encapsulation means whatever is there inside the object, you sort of restrict its access to other objects. Okay, so you encapsulate something inside the object, you hide it from the outer world. Okay, so for that we use these access modifiers. public, private, protected. We use these access modifiers to encapsulate the data of an object within the object. Okay? So in encapsulation, what do? We basically define fields as private and provide getter and setter methods, and we make these methods public. Okay, so first let me give you an example. Close this. Okay, so let's assume we have this name and age. Okay, so let us say earlier we made the name and age public so that other methods were also able to access them and also modify them, right? So in main method, what did we do? We were able to change the name of the person or give a name to the person object. Okay, suppose I don't want to allow that. I don't want any other method to be able to access the fields in my object. Okay, so all I need to do is I just need to make each of these private, name and age. Okay, and this introduce method is independent. Right now let me comment it, and what I will do, I will create a public method which takes the name from the user and sets this variable to that name. Okay, so what I will do, public void set name. What does this do? This takes a name as input from the user, and we can use some logic now. Okay, if you directly use the field, you can't use any logic. The field doesn't have logic, right? Only function will have logic. Like if else conditions you can give inside a function. If you just have field, you can't use if else conditions. So what we can do is, first we will check if the string is null or empty. Okay, if it is not, only then we say this dot name equal to name. Okay, so now we have added an if else condition to check if the input string is empty. Only if it is not empty, then we will assign that as a name, as this user's name. Otherwise we will not do that. So this is not possible if you just use the field directly. Okay, more complex logic we can use. We will see more examples later, but this is a very simple logic. Okay, So this is to set the name, I mean to give value to the name, and then we will have another method which allows other classes to get the name of the user. Okay. So now I can access the name of the person only through these methods, not directly through the fields. So now name and age are private. For name, I created two methods, set name and get name. So the user can give an input, and it is through this function that the user is giving value to the name of the user, to the name of the person object. Okay. If this method is not there, user can't give value to the person. For age also we can similarly create set age and get age. Okay. So that we will not worry about right now. So where is program? Okay. So we need to, now suppose if I try to run this, it should not run because these statements are now no longer allowed. You can't directly access the name field, name, age, or whatever, you can't directly access them. Okay. But let me just run it and show. Okay. So yeah, semicolon after method or accessor block is not valid. Oh, this one. Yeah. Yeah, type or namespace definition or end of file expected. That is line 24. So let me remove all this. Okay, let me remove this as well, this as well. Okay, now let us see. Yeah, still it is giving an error. It is saying type or namespace definition or end of file expected. Basically this is not allowed. So if we want to give name to this person, we have to use the function set name. You see it is suggesting set name, and that is the, yeah. So suppose I say this, and now I say get name. Okay. And here I should not write set name equal to Ravi. I have to pass this as input to the set name function, right? Okay. And here I have to print it. Fine, this should work. Okay, get name will only return the name, it will not print the name. Once I get the name, I have to print it. Okay, so okay, there is some error here. 24 some bracket. Okay, I have to comment this. Let's see. Now what? Okay, it is not void, it has to be string. Yeah. Okay. Yeah, worked. Okay, so the name field is private, but you are able to access it through public methods. Okay, it is only through these methods you can do whatever you want, and so the programmer can decide what to allow, what you can do with the fields. You can only read them, or you can't even read them. You can change them, or you can't change them. All these different kinds of things the programmer can allow through these methods. Okay, so these methods can be made public, but the fields are private. Okay, those are accessible only for the methods inside the class, not for outside the class. So that is an example of encapsulation. All right. Okay, so now let us move on to inheritance. So inheritance, you all know, like superclass, subclass, or a parent-child relationship, right? Say for instance, we have this this interface of this notebook that I am writing. Okay, now here there are multiple things. Say I can so this is like a text box, right? So this is a component in this tool or platform, and similarly I can have an image. Okay, I can insert an image, or I can insert maybe a table, right? So basically imagine it's like a PPT where you can insert different elements. You can insert text or image or table or some geometric shape. All these things you can insert, you can add to your presentation. Now each of them will have some independent properties, some specific properties, and at the same time some common properties. Like in the sense I can cut, copy or copy paste any of these elements. So copy paste is not element specific. I mean, it will be applied on an element, but it is common for all the elements. Copy paste can apply on any kind of element, but say number of characters, that is applicable only to the text element, right? Or number of rows and columns, that is applicable only to the table element, right? So there are some object specific properties and there are some common properties. Okay, so these common properties we can put in a parent class, so that we need not worry about repeating these common properties for every class. So each of these classes we need not worry about, okay, add a copy element, add a cut element, or add a height and width. Again, height and width is common for all the elements. For text element also you will have some height and width. For shape also you will have height and width. For table also you will have height and width. For image also you will have height and width. So all these are there for all the elements. So rather than adding separate height and width columns for every kind of object, we just add a parent object and we just add height and width there, so that those are inherited by all the elements. Okay, so it is easier for us to make our code simpler rather than repeating regular common elements, common properties across all the children. Okay, so how do you represent this? This usually you represent in sorry, it is in this mode. So this you usually represent using UML diagram. Okay, so before that, so basically what is inheritance? It is like it is basically simply put, an is a relation, right? Like, for example, we say a car is a vehicle, right? So there are some properties common to all the vehicles, and there are some properties common to, specific to a car. So vehicle is like a parent class and car is a subclass. So car inherits all the properties from the vehicle. Okay, so that is an example. So how do you denote some inheritance relationships using UML notation, right? So the previous example we discussed just now, like you can think of a presentation object as the parent class, and it can have different child classes like text object and image object and table object and some shape object like geometric shape, right? So all these inherit their properties from the presentation object parent class. Okay, so this is called parent class or base class or superclass, and these are called child class or derived class or subclass. Okay, all right, so let's look at an example. All right, so I need to remove this. Let's remove this. Okay. Okay, so let me create another file that is presentation object. Okay, so we'll say public class presentation object, and suppose I want to create another class, say text, which is a child class of presentation object, then all I need to do is put colon and the name of the parent class. Okay, and here you don't put round brackets because it's not a method, it's a class name. Okay, so there will be some fields and methods inside presentation object, and there will be whatever specific fields and methods inside text object. So whatever are there in the presentation object, they will be inherited in the text object. You can also have another class like image, which also inherits from the presentation object. So image can have say a method like crop, right? You can crop an image. So you can have public void crop. Say so right now let's not worry about the specific implementation of this method. Let's assume whatever how you crop an image, suppose that is done, you just print a message saying the image is cropped. Okay, so this is specific to the image, but almost any presentation object will have some common properties, that is like width, height, right? So we can say public, we can say double width, height, and any of these can have a method like copy and paste, right? So public void copy. Here also let's not worry about the implementation details. We'll assume copying is done. It will just print the object is copied. Okay, and similarly paste, here we can say the object is pasted. All right, and for text we can have a method like which takes some text from the user and or text can have font size, right? Font style, font size, and so on. So we can have int size, font size, string, font style, and so on. Okay, now if we look at this, so suppose I create a text object. Okay, I will say text t1 equal to new text. Now when we say t1, you see it shows the properties defined in t1 as well as the properties defined in presentation object, right? What did we define in t1? Font size and font style. This is what we defined. And what did we define in presentation object? Copy we defined, and height we defined, width we defined, paste we defined. Okay, there are some more properties, some more fields which are neither in the text class nor in the presentation object class. What are those? Like get hash code, get type, toString, right? Or equals. These properties are coming from where? These are defined in a class called object class, which is like the parent class for all the classes. That is a system class. So any object or any class that you define, that is a child class of this object class. So it will inherit automatically from the object class. Okay, so some are user defined classes and some are inbuilt classes. All the user defined classes are children of an inbuilt class called object class. So whatever properties are there in the object class, they will inherit from that automatically. Okay, so that is one thing which I wanted to say. Suppose I define a presentation object. presentation object obj1 is new presentation object. Now let us see what attributes this object one will have. You see, it has only those attributes which are defined in presentation object and its parent, that is object class. Okay, so what did we define in presentation object? Width, height, copy, paste. 2 fields and 2 methods. So width, height, 2 fields and copy, paste, 2 methods, and all the remaining methods are coming from the object class. That is equals, get hash code, get type, toString. These are defined in the object class. And you also see the symbols here. These symbols tell you whether something is a field or a method. Okay, so that which is like a cube is a method, and that which is like a cuboid is a field. Okay, yeah. So what else? You will see a lot of inheritance statements in Unity code. When you write, you need to inherit some existing functions from Unity classes. Okay, so inheritance is important. Okay. Yeah, any doubts so far? Okay, so if there are no doubts, we can stop here. So today we discussed encapsulation and inheritance. All right, encapsulation is access modifiers. We discussed basically private access modifier, public you anyway know already, and inheritance. Okay, parent class, subclass, which you sort of already know. Okay, so in the next couple of classes we will discuss some more properties like polymorphism, etc., and then we will be done with C# basics and C# whatever important concepts that are necessary for Unity programming. Then we will move on to actual Unity game programming. Okay, so let's stop here.